Hi, today we will know how to determine the focal length of a convex lens. The rule: 1 over f equal 1 over p plus 1 over q, where p represents the distance between the object and the lens, while q represents the distance between the image and the lens. If 1 over p equals 0, so 1 over f equal 1 over q. Also, if 1 over q equals 0, so 1 over f equal 1 over p. And this is what explains why the graph should intersect x-axis and y-axis at the same value. If we will plot the relation between 1 over p and 1 over q. The graph. This is how it would look like when you plot it correctly. Pay attention, you will record here the values of p, then you will get the reciprocal of each value. Also, you will record the value of q here and find the reciprocal of q. Then the graph will be between 1 over p on x-axis, 1 over q on y-axis, and on plotting the values from the table, you should have a straight line like this, which intersects with x-axis and y-axis at the same value. This value represents 1 over f. Thank you. To determine the focal length of a convex lens, we need to set the optic bench like this, at which we will stand the ruler on two metallic stands. The lens will be between, in its holder, will be between the object, and here it will be represented by this candle, and the image will be represented on this screen. So, at first we need to turn off the lights. As you can see, there is an image formed on the screen, but it's blurry. So we need to change the position of the screen till we get the clearest image. At first, we will begin with a very long distance of the object. And we will determine the distance between the object and the lens. Don't forget, this ruler is scaled, so you can read the distance between the object and the lens from the scale. So we will take the readings of the distance between the object and the lens, then the distance between the image and the lens, to substitute their values in the rule we will discuss. Then we will get the lens closer to the object. It means that we decreased the distance between the object and the lens, so the image disappeared. Move the screen that will receive the image of the object till we get the clearest image. Then read the the distance between the lens and the object, the image. Again, change the distance between the object and the lens. You will get a blurry image. Get the screen closer. You will get a better image. So, read again the distance between lens and the image, distance between object and the lens. Repeat these steps at least for 5 times. So you can get 5 points to plot on the graph. Again. All these are trials, so you can use them to determine the focal length, as we will discuss later. At this point, you can't see the whole image of the object because the magnification increased. Don't forget, each time you change the distance between the object and the lens, you have to redetermine the distance between the lens and the object, the image.